幸意外捞到一位外籍演讲者。我们其实，在我们的讲程里面，我们本来排了一位台湾自己能够分享在气候的部分，跟我们的环境跟我们建筑有关。那就像我们一开始的时候 ，I'm going to speak Chinese。因为我们在一开始的时候讲到，就是我们这堂课呢，在上学期的部分跟下学期是有区别的。下学期我们会着重在实物的部分，可上学期我们比较会希望谈一个生态建筑的全观面，比较宏观面所以上星期呢，其实我们请到台大的老师来跟我们教授跟我们演讲的分享是有关于土地伦理这一块，也就是我们现在 IED 常会强调的所谓的社会责任跟那个我们的这个职业的这个社会责任然后社会伦理等等，或者职业伦理。那有一堂课呢，我一直邀不到我们国内的很重要的一个潘成林教授是讲有关于气候部分。不过我们今天真的很意外，是中兴大学林子平老师今天没有办法来，不过他们2位研究生也来了。今天帮我们带到这位德国教授，今年应该今天是这次是第5次来到台湾。那么他在这个气候的部分呢，有关于气候的部分，那对于环境的规划的影响因子，他在德国呢，其实已经做了非常多年的研究。那国内相对的来讲，我们对这方面是比较晚的。其实我今天早上参加了江泽民老师在我们学校商学大馆的一个这个空气品质的座谈会，在里面去传达一个非常重要的讯息。然后这是一个实验的趋势，也就是建筑它不会只有在我们的领域了，它开始必须要更积极的去跨领域。OK， 那所以呢，这就是为什么我们在上面的课程当中，你会发现怎么这堂课前都不是建筑师，而是很多其他的背景的专业的知识必须是支撑你。那因此建筑的学习，你就会发现不在以前只是视觉的导向，你会发现你需要做一个很完整的，或者是对环境更负责的建筑。就像范总他一开始讲，我们怎么样做一个更友善的一个界面，透过建筑来去做处理的这样的一个操作的一个态度，那必须是更全方位的来做一个关系。所以，当全世界的地球暖化的危机，以及全世界所有因为气候变迁的所产生的议题，不要认为跟建筑没有相关，跟建筑是有直接很大的冲击关系。今天早上我听到演讲，他还讲，已经从低碳的谈到不是只有零碳，而是有没有可能 minus carbon 这样的一个概念。OK， 能不能透过所谓的极端气候当中去谈到我有没有可能负碳的概念，是让我们可以不要对环境造成负担，甚至我们能够更积极贡献。我觉得这都是非常非常新的议题，在建筑在全世界的领域当中在谈，然后建筑肯定是一个非常大的。好，所以今天呢，大家的这个一开始不要很怀疑，我们又请的又不是一个建筑师，好，那我们在每一次的演讲当中都要把这样的一个专业背景让大家了解一下。今天呢，我们非常非常荣幸能够请到我们德国的学者 Professor Andreas Mazarakis 然后来自于德国的演讲学者，那他的背景呢其实非常特别，是气象科学研究方面。那在德国目前是在弗莱堡大学，那他的这个越来越多的学生，他今天刚提早来跟我分享，开始有慢慢越来越多的学生研究建筑的背景的学生去找他做这方面研究，所以可见，就说各位同学，我们即便是专业的建筑背景当中，你还有好多选择。以前建筑人以为只能做室内啦、做营造、做建设啦、做灯光，你会发现现在建筑跨领域的格局越来越大。那我们今天很高兴请到我们德国的教授 Dr. Andreas， 他可以跟我们分享很多这一方面的有关于气候跟 planning 方面的议题那今天主要的这个主题是 climate as key factor in planning， 就是气候呢在我们的 planning 当中怎么扮演一个非常致命的最重要的因子。好，那它的影响一直在2个层面。那因为呢，我们今天演讲者要求是全程英文，不要翻译哈。那他说他照片相对，他的提供图片相对简单，然后他的英文也相对容易。那所以我们就试试看同学们的英文能力啦哈。那这个试试看体验一下。然后呢，因为在中兴大学的演讲呢，同学们有非常多的提问。我希望今天我们的方法同学们也能够待会我们演讲者到3点半哈。如果2点半就结束，你有1个小时时间可以提问哈。所以老师们、同学们要记得要轮流发问哈，所以认真一点听哈。那每个同学都有责任哈，待会不要点名哈，自己认真一点，然后提出问题做交流哈。那听说我们的演讲者非常 nice， 你提出任何问题他都会很乐意的回答。好，那我大概先对我们演讲者的背景哦，从气象科学的一个背景，走到现在最新的生物气象学跟一个环境规划规定。大家都知道哈，我们的传染病啊，很多的疾病啊，甚至跟我们的饮食、跟我们的环境都跟我们的生物跟气象有绝对的关系。好，那因此呢，我们这位教授呢，他就从本来的气象的科学，慢慢这个已经走到了这个 biometeorology， 生物气象学方面，那甚至跨到跟环境的一些 那我们是不是以最热烈掌声欢迎我们 Dr. Andrews？
Very much. I got only the last sentence.
Yes.
Yes. Can we turn
Turn up the light? Okay.
light?
关灯一下。
Yes. Thank you very much for the introduction, ladies and gentlemen. Don't scare. Don't scare. My English is very simple. I try to speak easy, understandable, so I understand myself. And I will talk today about climb. You can see that I will try to make to you familiar something that you think that you know, but in a different way. And I have put the parenthesis here, urban planning, because most of course the method that we use and have developed, you can apply it for many kinds of planning, but I will refer mostly in urban planning because the examples that I have with me is urban planning, or especially for Freiburg. Oh, Freiburg. Do you know where Freiburg is? Of course not. Freiburg is lying exactly here, it's at the border of France, Germany, Switzerland, in the foothills of the Black Forest. Not the Black Forest cake, but really the forest. The forest is not black, it's green, but it's dark green, but it's black. Okay, Freiburg is a city you will realize that a little later on. It's not a big city like Taipei or Beijing. It's about 230,000 population and so on, but has a long tradition in climatology because of the specific location, specific situation. I have structured my presentation in an introduction. I will tell you the story about the development of urban climate studies in Freiburg. It is not the city who has the most knowledge about climatology in Germany. There are also some other cities, but it's one of the first, one of the top 5. And I will tell you a story then about the master plan they made. It's a funny story. It has to do with much money. Finally, we didn't have so much time. Okay, and I will present you the integral analysis, not talking about temperature and so on, but also what happened, what kind of information has been produced and delivered then to planners. And then I will talk about what happened after the study, after this analysis, about the postmaster plan, what happened. And then I will talk something about examples. You see here some strange things about political pressure or social pressure, what really people can do. And I will talk about typical microclimate, bioclimate, what possibilities we have, how we can manipulate that and so on. And finally, of course, about climate change. And also, of course, the issue of adaptation, because I think architecture and planning deals more with adaptation. And of course, finally, some conclusions. And the first aim of mine, and I would like to describe it in that way, the reason because I'm here, is why is for you, it doesn't matter if architects, planners, and other kind, why is weather and climate important for you? So, and we have to solve the problem from the beginning. Climatologists, meteorologists think in a different way. When you deal with weather, like a typhoon or something like that, it's weather. It's a shorthand. But you can have a huge effect because the extremes can damage a lot of things. But when you deal with climate, it's long term. Usually we take a period of 30 years, and here, in order to describe this, it's not enough to describe it one typhoon or something like that, but you can describe it like the means. Precipitation in kilo is about 3,000 or 3,500, but Daiju is only, I think, 1,500 or something. You see, in a distance of 150 kilometers, we have double. This is in terms of precipitation, but not in terms of temperature. So this has to be described, but also in extremes. How often a typhoon can take place or something like that. So now I'm asking you how you consider all this information in your planning process. Okay, but we have a new situation. And the new situation is that we have all these terms on this fears about global warming, climate change, and we will not survive in the future. I don't like these headlines in the newspaper, but we will face new situations. Not now, maybe not tomorrow, but maybe in the future, or in the very fast future, but also in the future, maybe to the end of the century. And it's not enough to talk, okay, I will, in the year 2900, I will be 140 years old. We have to think in a different way. So the question is now, how all this, like weather, climate change, can be now assessed and quantified in an easy and understandable way. That is, we are here in the fridge between several disciplines, and as we know, the biggest difficulty that we have there is the communication. So, and I will try to show you some things. In order to give you this impression what we are facing, I have with me a wonderful picture will be the next one, which has to do with architecture. This is the building of climate. And so, concerning the future, we're dealing with adaptation, we're dealing with mitigation, we have the political issue here, like governance, politics, Kyoto Protocol, and something like that, and blah, 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 many things. But finally, it's a building, and we have to keep this building. But we see all, or most of the disciplines that we have, most of the disciplines that we have that are included. And here in the basement, we have the science, and we have some terms like agriculture, deforestation, drought, ocean circulation, sea level rise, CO2, data, melting glaciers, alternative energy, renewable energy, productivity, uncertainties, ice sheet, many things. But we deal here with climate, which is the basis. But don't talk about climate change, how if in the future, with the end of the century, Tavan temperature will increase here about 3 or 3.5. I'm talking about the communication, about how to deliver information, how to bring this information. I know about the uncertainties or possibilities of my models and the situation in climate, but this has to be communicated, but we have these always interactions. And there's one thing that's for me important. Only 2% of the Earth's surface is cities. But more than 50% of the people live in cities, and more than 75% of the CO2 emission take place in the city. So we have really focused what happened in the cities. And the cities have a specific climate. The city is something, for me as meteorologist and climatologist, nothing more than like a disturbance. And here we have a disturbance in the physical and chemical condition of the atmospheric boundary layer in weather, time, space, but this is not only horizontally but also vertically. And in order to quantify this, we take the characteristics of the city. These are 4. The first one is the city is a flow obstacle. The second one is this flow obstacle has an increased aerodynamic surface roughness. Finally, it's a heat island because most of the heat is released and exchanged here, not only CO2. And we have different patterns in the city where areas are more hotter or more warmer than surrounding areas. And finally, a city is a source of emission of gas, of particles, and vapor. And all of these different causes that we have here, or the characteristics, produce different urban microclimates, because this is really a disturbance modified by the obstacles that we have. Then we have also the indoor conditions. We must spend our time indoor, the urban planning, and outdoor. So we have here the connections. Microclimate don't belong to the meteorologists. Okay. So in order to quantify this, how to do and how to perform all this, I have to know what is the cause of the most known phenomenon, the urban heat island, or urban heat archipelago, in reality is an archipelago. And so in order to see that what happens, we analyze this in terms of the urban characteristics, but also of the energetic effects. What energy is really released and exchanged. Meteorologists are simple structured. They deal only with the energy exchange. But it's the most relevant for us. Okay, and when we see the urban characteristic that we have most in the city is we have increased surfaces. I have a multiple reflection because of the buildings and so on. I have the horizon when I see above is lower. That means I have the radiation cannot release, cannot disappear to the atmosphere. That means I have here a modification, and I have a lower wind speed here. That means less turbulent wind. The second one that I have is the air pollutants in the city, and that means concerning radiation, a higher atmospheric radiation. And then I have the third part, which is the heat emission from buildings and burning processes, which means an anthropogenic induced heat. That means I have more heat in the city. And finally, the building materials. Higher heat efficiency and capacity, increased heat storage, and less water can run off. And now I would like to ask you, which parameters or which factors are these factors who influence mostly in order to create an urban heat map? Most of the people here will tell that don't see heat emission from buildings and burning processes, that's right. But the reality is the lower free horizon, because you have bigger and huger surfaces where the energy exchange takes place. That means in order to do that, here is for European cities lower free horizon and higher heat efficiency because they store the heat. But if we look here in the tropical cities because of air conditioning and something like that, these are the three factors which have the highest relevance. So we see that there is a possibility how to describe the changes or the differences in the climate, the modification in the cities. In order to run this, we have different perspectives and different views. We can run this in terms of exchange of energy as presented here, but it can be run and analyzed in terms of energy consumption, but also for emission of pollutants. Most cities are polluted and so on. Greenhouse gases, as I mentioned before, physical and chemical properties of urban fabrics, deal more with architectural building physics and so. But finally, there are also some other factors. We have to think about that. When we analyze something, what is the target of that? We deal with the urban heat island, we want to quantify the urban heat island, but for what? For whom? I have started 1 year ago or 8 months ago in Germany in the mass media a very strong discussion with the urban planners. At the moment they don't like it. Maybe in the next year we will be again friends. And I ask them, what is the target? When you plan something, what is the target? For me the question is quite easy, is the human. Well, the humans live in the city. So now I want to quantify this for humans. Of course it has a relevance, energy consumption, something like that, but I live in a city and I want to have a better quality, or I want to keep my quality of life. In order to do that, we know from biometeorology, as mentioned, I'm biometeorologist, or I describe myself as biometeorologist or bioclimatologist. We know that when we want to describe the effect of the atmosphere on the human, that air temperature is not enough. Can you imagine what will be happening here inside in this room? We will remove air conditioning. No one will feel good of us. But the air conditioning we have in combination because of the reduction of temperature or for the wind speed. But if you go for the same conditions, we will move outside and we will be exposed in the sun. Nobody like that. The woman from Taiwan, the girls will open the umbrella or something like that. So you see that we cannot describe it only with one term, but we describe it based on energy exchange. This is the human body, and we know meteorology, but this is one possibility. Of course, we have also radiation, air pollution, and many other factors, but I will remain mostly in the method here. And we describe this in a combination of air temperature, humidity, wind speed, and radiation. And we don't take the energy exchange of a surface or of the city, but we take the energy exchange of the human body. And finally, we have not an information like a radiation watt per square meter or something like that, but we have an index which is described in terms of a temperature. And the results that I will present here is the physiologically equivalent temperature. There are also some other index. And no, it's difficult to understand the concept of physiologically equivalent temperature. I will describe in the future as PET, PT, and so on. We make it in that way. We have someone standing outside, exposed in radiation, vapor pressure, temperature, and so on, and we calculate all the body parameters, core temperature, skin temperature, and many other things, and then we transfer the conditions in the human inside, and describe here, and check which temperature is existing with the same effects. And this approach is valid, you see here, also for other indices, like not for architects and farmers, BMV, visible from Fenger, PET, SETs are perceived temperature, PCI, which is mu. That means finally we get a temperature which affects outside us, but we feel it inside or something like that. So, and it means that for Europe, PET is 20, means thermal comfort. For Taiwan, is 24, 25 to 29, something like that. We have checked that with some analysis that we have done here in Taiwan. That means I have a value with them, with it, I can describe all these effects. So it's quite easy. And then we have also some thermal classes, and we have some grades of physiological stress. Anything that is higher than 35, for Taiwan is 38, means strong heat stress or extreme heat stress. And these classes have been adjusted for several countries. We have started, of course, with Taiwan. Israel is just finished. Nigeria is on the road. Greece is also on the road. And Hungary also. And finally, we will do it also at the moment. We are doing also for Brazil and so on. And also some other countries. So that means we have a possibility in order to describe the effect of climate and humans, the traditional climate. Good. And now you may me ask you how I do that. Can I take my personal computer, the small computer that I have, or my mobile phone in order to calculate it or something like that? It's not needed. We have developed software. We have that ones where you can see the buildings, you can see the easy configuration, complex configuration, and so on. But you need some information like temperature and humidity, and you can run radiation, and finally you get all these indices. But you can deliver also some other information like shade or sun orbit or sunshine duration, and so on. Okay, this is existing, and I have to mention this tool, especially this tool called Raymond Professional. It's free on the internet, anyone can download. Of course, you have first to register, and then you will get it. Yeah. Okay, but it's free. So we use this method in order to describe all the indices that we have, that I have shown in transparency before here, or TMP, SET, star, PT, and okay, that was my method, which I described. Of course, I have some additional other methods in the maps, which I'll describe later. But this is mostly the basic analysis or the basis that we use. Germany, this is the Upper Rhine Valley, Black Forest, this is Freiburg. And we had in the past a long history of climatology, because Freiburg, as you see here, this is a valley here. This is a bigger valley here, this is Switzerland and so on. We have a specific situation there, also because of the location. And we have a specific wind which takes place about more than half the days of the year, called Köln-Teller, I will explain that a bit later. And in Freiburg was a long history about climate. 1973, it was the city where the first car traverses measuring with cars and so on has been developed. And we have the German, a branch of the German Weather Service dealing with biometeorology. We have the university with few institutes who work in the topic, geography and meteorology, our institute. We have also 3 consulting services with 20 people who work in the topic. And Freiburg thinks that it's the environmental capital of Germany. I don't think so, but I will leave them to think that. And 2001, was announced the Master Plan 2020. They want to check areas in the city to be reconstructed or constructed new and so on. And Then we performed an urban climate analysis, finished 2003, and our institute had a scientific supervision, that was our director, and the analysis was mostly done by two private companies, and these two private companies had contributions from the university concerning compounds, air pollution, and something like that. And finally, one Greek, that was me, contributed also to the analysis in order to test these methods or develop further the methods. Okay, again, this is Freiburg. This is the forest, the black forest, the valley. The area of Freiburg here is about elevation 800-900 meters. This is the inner part of the city. There are some small villages here, and you see here concerning the land use, the inner part is here, and we are lying with the food. Okay, as I mentioned, because of this topography that we have, during the day, the air masses in the valley, because of the slopes, are warming and warming. The air is lifted, but if air is lifted somewhat from the side, air has to come. So, and there is here something like a tube where the air masses go in the valleys, especially in this valley. During the night, when the slopes get cooler, colder flow is produced, or colder is not cold, a little colder air is produced, it's not cold, and then the air masses flow here over the city. And this phenomenon is known for many centuries, and people think that without this wind called Höllenteller, it's the valley of hell, Höllenteller, they think that if the wind will disappear, the people in Freiburg will die. Some will die, but not much. And 10 years ago, no, 20 years ago, Freiburg was a small city, had the football soccer team, was in the second league, not in the first league, and then get up to the first league. And the stadium is something about here, it's a small stadium, about 20,000 fans or something like that. They want to begin to make it bigger because of the first league, and they want to make it higher, about 10-15 meters, and there was of course a revolution, nobody wanted it. Finally, because of the pressure they made only 5 meters, because they thought with 5 meters the wind will not be influenced. So you see that there is something like environmental sensitivity there. And don't ask about if they really understand what happens there, but there is a sensitivity that they don't want to change something,